In this video, we will solve the multiple choice question as an exercise for chapters 6, 7, and 8. In this question, if cosine of 2x minus 8 degrees is equal to sine of negative x plus 10 degrees, then what is the measure of the acute angle x? So first, check the relationship between this. We can see that we have a cosine and a sine, and we know that they are cofunction, so it means the angles are complementary. And when you say complementary, then the sum of the angles must be 90 degrees, or that is the use of complementary angle theorem. So what we're going to do is we will add the two angles and we will equate that to 90 degrees. And then solving for x here, combine all the x and combine all the constants, then we will get x equal to 88 degrees. So the answer is C. And then for the second question, if cosine squared of 2x minus 8 degrees is equal to 1 minus sine squared of negative x plus 10 degrees, then what is the measure of the acute angle x? So here we can see that the relationship of these two, they came from Pythagorean equation. So this is from Pythagorean equation, like cosine squared theta plus sine squared theta is equal to 1, or Pythagorean identity, I mean. So here, what we want to do is to isolate the cosine squared. So let's try to isolate the cosine squared by moving sine squared on the other side. So we can see here that the identity which is equivalent to the given is cosine squared theta is equal to 1 minus sine squared theta. And we know that this is an identity if the angles are equal. So what we're going to do is we will equate the angles. So we will get 2x minus 8 degrees is equal to negative x plus 10 degrees. And then solve for the value of x, combine all the x terms, and combine all the constants. So we will get 3x equal to 18 degrees. And then dividing both sides by 3, so we will get x equal to 6 degrees. So the answer is letter B. The next question is, given the graph of the function f, which of the following is true? So you can see that the graph is a graph of a polynomial functions. So for letter A, it says that the number of turning points of the function f is 3. So let us check. So the first turning points is this. Turning points means the function changes the direction, or you can see the concavity. So this concave up, so that's 1 point. And then another is this concave down, and then another is this concave up. So we have three number of turning points. So letter A is true. And then for letter B, let's try letter B. The leading coefficient of the function f is a positive. So referring to the leading coefficient and degree of the function f, so we can recall these four graphs. As we can see, this graph is similar to the first one, wherein if the degree is even, then the leading coefficient is positive. So it looks like this letter B is also true, and letter C is also true. And you can also check the rest just in case, or for some more information. So if the graph on both ends is decreasing or going down, so this is an even degree and the coefficient is negative. So as you can see, when both ends are both increasing or decreasing, so they have an even degree. So it's up meaning positive, it's down meaning negative. So, and also when you can see that the graph is opposite like this, so the degree of the function is an odd, and it's positive if the right is positive, and the coefficient is negative if the right is a negative. So this is just an additional information, but we are referring to this graph, which is the first one here. So we make use of this to be able to answer letter B or C. And then for letter D, it says that the number of zeros of the function is 4. So where are zeros of this function? We know that zeros of the function are the x-intercepts. So the x-intercepts are these points, 1, 2, 3, 4. So there are 4 x-intercepts, meaning there are 4 zeros. So letter D, it looks like this is also correct. And for letter E, it says that all of the above is true. So we will select letter E. because all of them are true. The next question is the x-intercept of the function f, which is given as log base 2 of x minus 1 with domain from 1 to 2, where 2 is included but 1 is not. And then another equation is square root of x minus 2, where the domain is x is greater than 2. So these are the choices. So let us try to get the x-intercept by setting y equal to 0. So first equation, it will give us log base 2 of x minus 1 equal to 0. And since this is logarithmic equation and we're solving for x, so we have to change to exponential equation. So make sure that this log is a positive and isolated. Since it's already isolated and positive, so we can now change this to exponential in form. Start with the base 2 and then power 0 is equal to x minus 1. So this is our equation. And then solving for x here, we're moving negative 1 on the other side. So 2 to the 0 is 1, then added by 1, the x value is equal to 2. And we can see here that we have to check if this x value is included in the domain of the first equation, and it is. So meaning we will accept this x-intercept. And then for the second equation, we will equate this to 0. So we have square root of x minus 2 equal to 0. And then moving negative 2 on the other side, so we will get square root of x is equal to 2. And then getting square root of both sides, so x is equal to 4. And then let us check if this x value is in the domain of the second equation. So since this x equal to 4 is greater than 2, so we have to accept this as x-intercept. So meaning the x-intercepts are 2 and 4, which is letter D. And then for the next given, so we have this expression of log base 2 of xz divided by y cubed w is equivalent to any of the following. So let us try to expand this. As we know, all the expressions in numerator, they are positive log. So we have log x plus log z with base 2. And then all the expressions in the denominator, we have a negative log. So we will have minus log of y cubed minus log of w with basis 2. And then after that, so we can just copy the first, second, and the last term. And then the third term, it will show us the power property, which is minus 3 log of y. And then this choices is in choice letter B. In this problem, the line y equal to 1 intersects the graph of the function f of x equal to sine x. So if we will graph y equal to sine x and y equal to 1, so it will show like this. Since we can see here that sine function, the domain is all real numbers, so the y equal to 1 intersect at many x values or many points. So meaning the answer is letter D, which is infinitely many times. And then for the next question, this function of log of x with the base a is decreasing if, so the answer here is when a is less than 1. And we know that it is increasing when a is greater than 1. So this is just for additional information. Now the next problem is the maximum number of turning points of this function is any of this. So here we can see that the function is with here degree 3, because if you will expand this, the highest power is 3, and then if you will expand this, the degree is 2, and here we have 1. So meaning this function is of degree 6, and if we have a degree 6 function, the maximum number of turning points is less 1 in the degree, which is 5. So the answer is letter C. And then for the next question, a function f is a one-to-one, and if the graph of f inverse lies in the fourth quadrant, in which quadrant does the graph of the function lie? So here, if we will check, the functions f and f inverse are symmetric with respect to y equal to x. So if we will put a given as a graph of the f inverse, let's say it's in quadrant 4 like this, and then to be able to get the inverse of this f inverse, so the inverse will fall in quadrant 2. So that's why the answer must be in quadrant 2. Now the next question is finding the x-intercept or intercepts of this function 2 to the x minus 16. So this function is an exponential equation, and to get the x-intercept, you set y equal to 0. So when y is equal to 0, so we have 2 to the x minus 16 equal to 0, then we will get an exponential equation. So here, since we have the base 2 and 16, and we know that we can change this with the base 2, so let's just move 16 on the other side, and then change the 16 with the base 2, meaning we have 2 to the 4, and these expressions are equal only if the powers are equal, so we will just equate them. So x is equal to 4, so the answer is letter C.